All right, welcome to Chapter 3. We're going to be covering the Java basics in this chapter. So, one of the things that I want to show you before we start this off is the phases of programming. This is a document that's in your Getting Started module that I thought is really cute because it really is a good explanation of how we move through the phases during an individual program. If you want to stop it here and read through them, some of my favorite are number 9, where you're pounding your head on the desk or you're pounding your computer because of frustration, and then we all end up in the chair talking to our therapist as we move through it. And you might be inclined to believe that these phases are programming from the start to finish of a single program, but I would be more inclined to tell you that these phases are what we move through every 20 minutes while we are writing a program. So let's get back to the program. We're going to be covering a few things. If you remember in our last chapter, we were talking about pseudocode. And so if I were to remind myself of some of the pseudocode to calculate a restaurant bill, I'm probably going to need to find out the bill amount, and then I need to determine the tax and the tip rate, and then I need to calculate the tax and the tip. I need to add those together and display them to the user. So as a part of a program, in order to write the program, I'm going to need to be able to store information. And we need to store it in something we call a variable. So if I'm going to create variables for this program, I probably need somewhere to store the bill amount. I'm probably going to need somewhere to store whatever the tax rate and the tip rate is. And then I'm going to need to store the actual value for the tax and the tip. And then I need somewhere to store the total when I add it all together. So I'm going to be creating variables to store this information in. And it's critically important that we discuss the naming conventions. When I begin naming my variables, there's a few things that I have to take into consideration, such as any name is going to be made up of, or can be made up of, letters, numbers, and some characters, some symbols and characters. But the one thing that has to be true is that they must begin with a letter. There are certain reserved words that we're going to be using as a part of our programming language, and the variable name cannot be that reserved word. The next thing we want to use is descriptive variable names. And then we'll talk about underscores and camel cases to make descriptive variable names. So let's look at some of this. Variable names. If I want to have first name, this is not a valid variable name because it must begin with a letter. So I could call it, say for instance, name 2. I could call it name 1. These are much more descriptive variable names. I can have symbols in there such as name underscore 1 and name underscore 2. These are certain symbols that I can use, but there are other symbols that I cannot use, such as, what about name plus 1? Do you think that I can use the plus symbol as a symbol inside of a variable name? I cannot, because the plus means something. The dot, the asterisk, the divide by sign, the forward slash. All of these have meaning and value to a Java program, so I cannot name them name dot 1 because that dot also means something. And there's one more symbol that we're going to find out means something. I want to have a descriptive variable name, so I want to call it first name, and I want to call it last name. These are much more descriptive than just name 1 and name 2, but I would ask you, what is this symbol that is right here between those two words? Well, it's a space, and so a space is one of the symbols that I cannot have as a part of a variable name. So if I want to have descriptive variable names, such as first name and last name, how am I going to go about doing that without using a space? Let's see. One of the ways that I can do it is called camel case. So I can have a variable, can decide on a variable name. I'm going to call it, let's call it first name. Spell it right. First name. While that is a descriptive variable name, it's not very easy to read. So one of the things that I can do is I can uppercase or camel case the first letter of each word. Say, for instance, customer, capital first, capital name. That is much more readable, right? because I have to mash the words together. I can't have a space in there. Another one of the options would be to use an underscore between each of the letters or each of the words in your variable. Now, I prefer using the camel case and for one reason and one reason only, because I cannot consistently find that underscore key on my keyboard, but I can consistently find the uppercase key whenever I'm typing values. So you're going to see me using this camel case as a way to have descriptive variable names that do not contain a space, mash them all together, but I want to make them readable. So you're going to find that I use that as a method for naming my variables, only because I can find the upper or the shift key much easier than I can find the underscore. You can try whichever method that you want. I would just encourage you that once you have found a method, try them out, try different ways, but once you've found a method, just be consistent. All right, so when I'm declaring variables, I have to have a name for the variable. Another one of the things that I have to have is I have to know what kind of data the variable is going to be holding, because each one of the different data types takes up a different amount of space and memory. So I can have whole numbers, and in Java there are 4 different types of whole numbers: int, short, long, and byte, depending upon the size of the number that I want to contain. I can also have floating point values, and there are 2 of those, a float and a double. I can also have a character, which is one single character. It can be a number, it can be a letter, it can be a symbol, but I can only have one of them. Middle initial is one example of a character variable. And then we can have a Boolean, which will contain the values true or false, yes or no, 1 or 0. And then I can have a variable that will contain a string, and that is alphanumeric, letters, numbers, symbols, anything in there up to 255 characters. And so I have to know the type of data that I'm going to be storing in order to be able to reserve space for it in memory. So let's come back and look at this really quickly. This is my representation of memory. Maybe it's because of what a memory stick looks like, but this is my representation of memory. And so I have some memory out here, and I have some spots that have things in them. And if I want to, let's say for instance I want to create a variable that will contain a whole number. What I need to do is when I declare that variable for the first time to contain a whole number, the variable int requires a certain amount of memory. And so at the moment that I create this variable, my computer goes out in memory and it's looking for the right amount of space. It finds that space in here, and then it is going to reserve that space in the variable under age. Then let's say, for instance, I want a floating point variable called, it might contain wage, a floating point. Well, if you'll notice, a floating point number requires, let's say, 8 bytes. I can see it on my screen here in 8 bytes. And so now I need 8 bytes. And so I'm going to say, for instance, that this is 8 bytes long. And so my computer goes out and finds the 8 bytes, and it reserves it under a variable called wage. That's one of the reasons why, or that is the reason why, I need to know the type of data that is going to be stored in my variable at the moment that I create it. Because if you'll notice, each one of these data types requires a different type of memory. All right, then your book goes on to talk about a number of the different operators, the math operators that are available to us. We're going to be talking about some of these shortcuts as soon as we start programming. And this is an example of the math operators in effect, although I'm sure you've seen math before. The last thing I want to talk about is the different types of program flows. Invocation is where I'm invoking or calling the program to do something. So let's see an example of invocation. Invocation is calling. So there's certain things that I'm going to ask my program to do, such as ask the user for a bill amount or print the total bill to the screen. And I'm going to be invoking or calling some source code that somebody else has written. That is the idea of invocation. Here, and for the most part, our programs are going to be top-down. Our program flow, we're going to start at the beginning, and we're going to move line by line by line through our text. All right, so this is an example of the standard structure of a Java program. We're going to use the words public class main, and that main is going to be the name of our program, so we might call it different things. And then I need an opening brace, and I need a closing brace. These opening and closing braces can be found by the letter P on your keyboard. There are curly braces, so I'm going to have to press the Shift key to get to them. This I'm going to call the class container. And inside the class container, we're going to have another class container, or excuse me, another container that I like to call main. And it uses the keywords public, static, void, main. And then I have some parentheses, and inside the parentheses I see the word string with a capital S. And then I see the square braces, which are on the same keys as the curly braces, but I don't press the shift key. And then I see an opening brace and a closing brace. And the braces are used to indicate the beginning and the end point of the container. So we have a class container, and inside of that we have a main container. And all of the Java program or the Java code that we're going to write is going to go here inside of the main container. So let's start writing some programs. This is the end of the first lecture, and we will start with writing some Java code in the next lecture.